Thank you.
You're on your own.
All right.
Take it away.
Thank you. I don't know if actually it's this one or the other one. It might be. All right. So, hi. Good morning. I think this is, yep, this is it. So I think he must have seen my slides because he's exactly right about what we'll be talking about. The actual Terminator is still in the lab, so we're not actually going to go into the nuts and bolts of how to test an actual T1000. We'll get there, but it's all the setup for it. But yes, let's just get into it. So there was a book written a long, long time ago by Jim Collins called Good to Great. And ironically, over the passage of time, most people think it's not actually a great book anymore. But it was then, mostly because it's guilty of survivor bias. And when you study only the successful companies, you find things that, like actually Simon mentioned this yesterday, but like there's a lot of problems with the process when they went through it. Also, in particular, the companies that they listed, like Circuit City as one of the great companies, doesn't exist anymore. Other ones were like responsible for the crash of 2008. We're also in there. It's just bad news, right? But there was one great idea that's in there, which hopefully will not be undone by the other data in the book. But there's this thing called the hedgehog concept, and I remembered it when I was first trying to find. This is perhaps popularized by him. I'm not going to go into hedgehogs, and actually involves hedgehogs and foxes, and it's based on a poem, and it's really complicated. But I found when I was searching for this, I was actually searching for like career guidance Venn diagram, because I've seen a bunch of people kind of do this, and it's hard to read here, but it's basically you want to, for perfect nirvana, happiness in life, you want to be at the intersection of these three circles. What are you passionate about? What can you be the best in the world at? What are you good at? And what drives your economic engine is a fancy way of saying like what pays the bills, right? I've heard it described in other different ways of like when you're trying to figure out, what you should do. It's kind of like there's passion is about what you want. What you're good at is also about you, and that other one, the money thing, is like what the world is coming to you for. Anyway, different, and it's almost like in the testing pyramid. 1 million people have come up with their own testing pyramids. The testing pyramids are everywhere. Same thing with these three circles and trying to live at the middle, and then funny little anecdotes about like what it means to be in not the center. Like this is everywhere. But for the kids, make an emoji, right? So at various times, if you get right there in the center, it's all happiness. I was going to use the sunglasses emoji, but on Apple it looks really kind of spooky. So I just went with the smiley face. And at various times, I've only been in 1 or 2, and briefly, sometimes 3 in the middle there, where something that I want to do also pays the bills. But a lot of my robotics projects don't have the money bag associated with it, which is kind of like this very frustrating thing. But flashback to my childhood, and I know I've already given this a little bit, so I'm going to go very quickly. 1984, my favorite toy, amongst a couple of them, was the Armatron. It's really, I'm just living the rest of my life just reinventing all the toys of my childhood. But this is a cool thing. But it was frustrating because it was like this toy, and I wanted to actually like do robotics for a living, but I never knew how to do that. And I also had like art projects around it. You could call it kinetic sculpture. There's a whole bunch of stuff that you can do with like art that moves. I call it like art that you have to plug in. I look forward to someday where you go to an art museum and everything is just a bunch of like little robot gizmos, and that's the modern art museum of 100 years from now, looking back at today. But skipping that, fast forwarding to 2008, Charles gave a version of it of the story. This is 2 dudes having lunch at the Googleplex is what happened in June of 2008. And I still remember this conversation. I don't remember all conversations. I apologize if I've met you 3 times. But this conversation was memorable because 2 weeks later I quit my job at Google and we started Sauce. So John, he's got this way of interrogating people. And he specifically asked, like, hey, if money was no object, what would you be working on? And I instantly went back to this slide, right? Like, oh, like in my happy moments where I'm doing all of these things, I'm good at it, I love doing it, people are giving us tons of money for it. I went on to describe this crazy art project, and I just immediately said like, oh, yes, if money was no object, imagine if you had 10,000 linear actuator pistons, and they're all lined up, and you could program them, it could be this like really cool Burning Man sculpture thing. Like, that's my first idea. That's the thing I would totally do. And then I've got this other idea, and he's like, tell me about that other idea. I was like, okay, well, so it's kind of like this, what I've been working on at Google for like the last year and a half. You just have these thousands of machines. It's almost like the art project, but it's like actually useful, right? Like you have 1,000 machines, you're spinning up Selenium tests, you're doing all kinds of crazy stuff, and then you get all the results back. And the really cool thing about that, though, is that there's this other thing called Amazon EC2. They just released it like a year earlier, and I think you could totally do what I'm doing at Google, like outside the Googleplex. You could do this like for everybody, or anybody could do it, right? And he was like, tell me more. And so I think it was like really zeroed in on that money bag aspect of that whole triangle thing. Anyway, so obviously we started Sauce Labs, and here we are today, right? Yay. In all of the meetings, talking to customers, investors, like anybody, when I would try to explain and translate Selenium, specifically like the media, it's very hard to explain, or even my parents, I call this like the Thanksgiving test, trying to explain to your relatives at Thanksgiving what you do. It's like, well, I connect to machines at somewhere in the globe on the East Coast, and I flip bits on a hard drive, and it make them do those things, and then I get an email back. And so I would usually just end up summarizing it as, it's like a robot. And this is the slide I would actually use. I think this is a robotics project in Japan. I think it was called like Fox, but I can't find any other link to it other than back to my presentations about it now. So like this weird, this weird memory hole on Google now. But it's a cool robot. So the thing was, after all these years of describing Selenium as like a robot, I was actually frustrated that I wasn't working on real robots, but that was kind of funny that I was almost there. But after a couple years, I realized like, no, screw this. I'm gonna maybe test my theory, test my metaphors. If Selenium is like a robot, could I make an actual robot be driven by Selenium to do things, right? So I wanted to make this a sentence. It is a robot, right? So this is one of the first, that's actually maybe the third generation of it, whatever. All right. And this, again, kind of an art project. The design goal was to play Angry Birds, back when Angry Birds was a thing, right? So we didn't know what to do with it, didn't pay the bills, but it's total, it's a spectacle, right? So we put it at the Sauce Labs booth, and people go like, what is that thing? And I was like, oh, it's a robot that plays Angry Birds, right? So and like, well, what do you do with it? Like, nothing, that's it, right? That's the demo. All right, back to work, right? No money bags in the Angry Birds automation industry. So as far as like if I had an artistic shtick, some people like draw in geometric shapes with only primary colors or whatever. My thing, I guess, is this reverse Tron. I've done this in a couple of different ways now, where I will take a thing that's trapped inside a computer and break it out of the computer. And so my playing around with robots is kind of my interesting way, or I think it's interesting, taking Selenium out of the computer and have it work in the world. So when I watched that video, the intro video yesterday, and there's robots riding on bicycles and failing at eating cheeseburgers and all of those things, that's that reverse Tron. That's all the stuff that's trapped inside a browser or in a mobile phone that if you can break it out of the computer, you can kind of, and give it wheels and legs and things like that, you can kind of do stuff with it. One interesting thing about that project is that it made Popular Science in February 2012, which was ridiculous. I never had thought to put that on a bucket list, but I got to put that on there and cross it out. I think it was, anyway, but it was there was a theme of the future of fun. Again, which is this killer thing, because it also means like, yep, no money there, right? But hey, like, that was cool. So the robot was in there. I kept on working on the robots and making them a little bit more practical. This one was actually, and one interesting thing happened with all the robots that I started putting out there, is that anything that's actually manufactured, like a physical product, there are secret robot labs all over the place. Every major manufacturer has one. But the weird thing is, the frustrating thing is, they're all trade secrets. They don't, car company A doesn't want to know, car company B knows that, that they've got robots tapping buttons on their touchscreens. So people come out of the woodwork and they talk to me, and one particular customer, they wanted to automate text messaging back and forth to iPhones, texting, and he wanted me to give a presentation and give a tech talk to a whole bunch of people. And I thought like 2 phones texting each other was gonna be kind of boring. So I figured the moral equivalent, obviously, is 2 robots playing GarageBand, right? Way better presentation. So, this is my desk at 3 a.m. before I had to get on a plane and fly across the planet. And then I can listen to that song all day, right? I'll save you. And so, if I can just pause it, right? So after the presentation, came up to me and said, like, Jason, that's great, good demo, but yeah, but can you really do the texting back and forth? because he specifically wanted to know, like, could you control 2 robots simultaneously? And I figured, like, ta-da, I just did. That's 1 computer, 2 robots, whatever. That ended up leading to a sale, so that was good, right? So anytime I randomly post a cryptic 10-second YouTube video with no context, that's like my bat signal. Like, hey, it's a party, right? Anyway, so I've worked on my, my again, no context demos. This was another request. Same client, actually. So this was like the next order. They wanted to get to the Android bootloader screen. And the only way to do it is with a robot. 2 robots, or 1, whatever. So you can get to the Android bootloader screen from a power off. You can either use a cable to do it, but that cable doesn't charge the phone, or you can, or there's a cable that charges the phone, but you can't do both. And so we could either like start splicing cables. Some other companies actually break apart phones and then jack into the electrical electrodes where the power contacts are. I know the company who was doing on that, and we were kind of comparing notes on stuff, and I was like, I just made this contraption, and they lost the deal. But anyway, anyway, so there's a certain level, like, I can't believe I'm doing this, right? This is, the art projects now actually have a use. Although not everyone in the room is doing Android bootloader login stuff, so there's really, like, I still have to kind of keep working on figuring out what the heck I'm doing. Different version. This is like now the latest version. Same client. They said, you know, the thing is great, but I really wanted to tap faster. And this is like, I'm going to freaking kill that because it's been a complaint forever. I think this might just go on. OK, it does stop eventually. I think I clocked it at like 700 or 800 taps per minute. And I'm also kind of going in the back. I've also Googled all of the tempos for all the songs on the planet ever. And the fastest song ever is like maybe 300 or 400 beats per minute. And this is like 700. So now I think theoretically, if I got Jonathan Lips in a room and we can start hacking on some MIDI translation stuff, we've got a potential robotic platform for doing really high speed, like heavy metal robot solos. Yeah, exactly. Right. Anyway, so there's this observation that, like, you know, test all the things. No one ever talks about no one never really makes the marketing T-shirt or slide about what the actual implementation of test all the things is. But the thing I've learned about Selenium and web testing and mobile testing, really through my crappy little robots, is that really you break it down to everything is just 2 things: finding all the things and then doing all the things to the things you found. And the reason why I've kind of stumbled upon this is because when everyone asks, yeah, so Tapster do things to things. But as soon as people see that, I don't have my robot, the other robots that are in there. People ask me, like, how does Tapster know how to find the things? And the problem is it doesn't. It's only half of that equation, right? It can do the things, but it can't find the things. And so I've been on kind of this quest that knowing that the complete solution is I'm going to have to add the finding the things part to make this a cool potential Terminator, right? I don't know. But if you fast forward, anyway, it's kind of a segue. I wear many hats, and one of them is I'm the coach for my kids' robotics club at their school. Yeah, go figure, right? And this is my son Declan, and then my son Finley is on the far right. You'll see. Not my kid in the middle here. You'll see.
Watch out!
And we are practicing for the competition.
Because
And
High five, Declan. High five, Declan.
nothing worse than just being lingering there for the high five, right? So they have a season where you get the kits in August. They have a competition in December. It's the first Lego League is the organization that it's like the curriculum behind it and the whole organization behind it. And the good and bad thing about this is we had 20 kids actually involved in this. You can only have 10 kids per team max. So we actually had 2 teams compete this year. And I guess the biggest frustration is that they're really expensive. I loved Lego as a kid. Hey, I even proposed to my wife at Legoland, California. Like, I'm super committed to this Lego thing. Armatron and Lego, right? And the thing is that these kits are like $400 a piece. And I think the other observation about the universe is that it's really obvious if you're teaching music to kids that if you've got 20 kids and only 5 violins, that might actually sound better than 20 violins, right? But maybe a different example, like just you want to have a one-to-one relationship between the instruments and the kids, but it's not so obvious, and everyone kind of like rolling out tech clubs now. So, but the other problem was financial, right? Like we didn't have the budget to do 20 of these kits, so we kind of had to make do with like 5 or 4 kids per robot for the team. Anyway, so this has been kind of a thing. So, trying to figure out over the Christmas break after the competition, like how could I drive the costs down for these robotics kits for the kids? Again, don't know really how it makes money, but I know all the money that I don't want to be sending to somebody, and I want to make it cheaper. And so this was kind of my thing over December, like just very recently, right? So fast forward to today, and one of the things I realized as I was going down this journey of like trying to make a really intuitive but cheap and easy to use kind of robotics kit for these kids, and then it reminds me of one of my other favorite toys from my childhood, Big Track, which I got one right here. They don't sell them anymore, so this is like totally, I need to hire security, right, to watch this. This is the British version of it. This is actually the remake. They remade it in like 2010, and then they didn't sell enough, and so now like these are the collector's items again, right? But they came out, dating myself here, but you know my birthday now, right? Like basically, I was a little 4-year-old in preschool, and this is how we learned to program. And of course, step 1 is like you just play with blocks. And then the second thing you do is now you have a robot and you have blocks. What you do is you set up the blocks, you set up the robot, and it's kind of like bowling. You just program it to roll until it knocks over the blocks, and that's like the most awesome thing a 4-year-old can kind of do. I'm not going to do the demo right now in person, but I've got a video of it. This is from my workshop just a couple days ago. This is kind of how it works. Program to go forward 3, turn right, go forward 3 again, turn clockwise, press go, and then it runs the program. So, and that's it, right? So it's very similar. In my mind, watching my kid make his little robot go around the table, it felt very similar to this. The other part of the cost thing that I was thinking of, like my little intellectual exercise here was, we also needed to have phones or tablets that go with it, but what could you come up with a robot that you could program that did not require any keyboard, video, mouse, whatever? Then that's another way to just from a very pragmatic, like get rid of the cost point of view. It's like, oh, it reminded me of this Big Track thing that had kind of a built-in keypad. But going one, like, well, hold on. Well, here's a modern day equivalent. Even though you can't buy this, this is another kit. They're everywhere now. I think this is like by Actobotics. And it's, that is a little kit for like 15 bucks I picked up at Micro Center, and a Raspberry Pi, and a motor shield from Adafruit. So maybe that whole thing is like $30 or $40. And that's the modern day thing that you could get. Again, kind of a echo of Big Track, right? I think also at the time, I'm holding a laptop and I'm SSH'd into that thing because it's Raspberry Pi 0, and I'm typing commands to tell. It's like, oh, that's kind of cool. But the key thing was I also got this other problem in my day job where like I'm trying to figure out how to tell robots how to know where things are, because the problem with the tech club kids, Big Track, or even this robot is that it's still flying blind. It still doesn't know what it's doing. And that just kind of frustrates me. So one idea is potentially add a camera, which is not in the video, but it's like right here. If you can use the camera to go find things and find way and have some kind of heuristics and like, how does it know how to find something? It takes an image, but how do you find all of the elements in the image to then know, oh, I'm going to go there and then click that button or knock over those blocks or whatever, right? And Simon touched on this yesterday. Why is browser automation possible? Or why is mobile app automation possible? And it's the DOM, the document object model. I'm not going to go into all the details, but like the DOM is the flux capacitor for test automation. It's what makes it possible. Even though there are conferences and books and experts, basically we have it easy because of the DOM. And the novel thing about what Appium was, what we brought kind of our assumptions about how we should do browser automation to the mobile world. We added the WebDriver API. We added kind of like the specific ability to introspect a mobile app screen and bring it back into an object model that you could then interrogate. That's kind of the key thing that you need to be able to make testing work, right? And going back to the robots, I know these are all tangents and segues and back and forths, and it gets a little dizzying, but my argument would be getting beyond the hype of all of these buzzwords that are very popular these days: augmented reality, machine learning, artificial intelligence. I would argue that augmented reality is a DOM for the real world, everything that you can kind of see. So I choked about this, right? Hashtag dad jokes, right? So now what I've been playing with is now I think I have a bead on an idea of how to do it. And augmented reality is like, unfortunately, like this $5 word now. But really, it's the how do I make my robots not blind? And if we can make our robots not blind by taking image inputs and then being able to find things then we can actually test all the things, right? So this is a demo from a couple months ago of this idea that I've been working on, specifically like giving vision to my robots, but being able to find the things.
All right, code cards, prototype number 1. Let's see if it works. All right. Let's get the window a little bit bigger here.
While you're watching.
Okay, can find all the cards.
So what you're seeing is the camera.
Yes. Sweet. It works. I can't believe it. It works.
It really was the live first version of this.
Fine, start.
I wonder if I can pause it. Oh wait. Yeah. Okay. So it was a camera pointing out at this piece of paper, and it doesn't have to be this piece of paper. The idea was to. I spent a couple days actually researching how to make your own custom like deck of cards, and you can actually do that. There's whole companies that can. Anyway, there's this idea where you could upload a little triangle, and that would be the start of the program. And this is the program to run that demo of Big Track. And ironically, only after running this, I realized there was a bug in my program. Because if you go forward 3 and then turn right and then go backwards 3, you're actually just going to turn around and then back up, right? So I only realized by running this code that I need to change the arrow, and then it actually is a legit program. So it really was behind the hype of augmented reality. It really is this. The magic is the OpenCV library, and there's some tricks here that if you play around with it, I highly recommend that you do it. There's some tricks. It's really good at finding hard contours and number of sides of shapes. So it's really easy to make sure that I add a hard border. If you ever see kind of an augmented reality, it's very often it's going to be a very thick black line around it. The cool novel thing about why everyone's so excited about ARKit on the Apple side is because these things are called markers, like the outline. And the whole magic about ARKit is that it's markerless. So you can just plop a couch right without having to put a gigantic black rectangle where you would want it to go. And then the other magic library that I'm using is this is specific font, and it's basically like again, these are things that are decades old, but like a specific font that's used for banking numbers. It's like OCRB is the font name that it's computer readable. And then I use a library called Tesseract that, more fancy buzzwords, machine learning. There is training data that you can download. If you use Tesseract with the OCRB training data, it instantly can read any number, right? So I kind of cheated by using, I'm not going to just write my handwriting. I'm going to use a specific font that's been engineered for effective computer vision with low error rate, and then using OpenCV to find actually I realized from my testing the octagon's not a great idea for the stop. It's a great idea for the stop sign, but for the computer, it gets confused. So I'm going to switch that out. Anyway, but it can easily find the triangle and these shapes. Once I start getting beyond the basic shapes, like this one, that was a little weird. The next version I do this, I'm specifically going to go through the machine learning algorithm stuff to train it to find these symbols. And these are all, they're not as cute as the smiley faces, but I haven't gotten up to the yet. These are all the emoji, right? Right now, you can kind of, like, there was this thing the last couple of years where you can go find QR codes, and everyone knows those are boring or lame. But I want, I guess the next version of that will just be emojis, right? So you can kind of go up, put it at a particular phone or a particular smiley face, and you can do it. Anyway, but going back to the tech club kids, without a computer or a laptop or a keyboard, potentially they could have all these flashcards and just put them down on the table, take a picture of their program, and then send it off to the robot. So you don't actually have the computer involved. There's another benefit for that, is that I want these kits specifically to be so cheap that they're kind of disposable. They're kind of like textbooks in the sense that they're not so special that they could go home. It's a big deal in lots of schools to like have, especially for like a 7-year-old or something, to have the iPads kind of go back with them to home. They'll forget them to bring them back. So I want this super cheap thing. So one thing would be like, oh yeah, you get a robot and like a stack of these little flashcards, and it has the camera, so you can kind of program it, right? So as I'm playing around with this robotics kit and this computer vision stuff for this thing, I'm slowly realizing that this potentially has applications for how we can get, how we can test all the things, right? And this now feels like I have a little bit more. I'm still serious about this thing, but I'm kind of beating a dead horse here now. At Selenium Conf 2015. I just copy pasted my next couple slides. I put out this idea in the universe that this WebDriver thing is really good. Good job, Simon. And it should be more applicable, but now it's kind of like this weird thing that the word web is now like this anchor to, like, the driver part is awesome, but the web part's now kind of like yeah, old school, right? So I was like, oh, well, what would be a good modern day rename for that, right? So star driver as like an asterisk as a asterisk is a wild card. And lots of programming languages, like, man, star driver, that just looks cool in black and white, right? And red. You got Star-Lord, star driver, it's awesome, right? And at the time, again, these are just my slides. I'm just totally copy-pasting these things. I said, like, hey, please, OpenCV and integration. And this was my idea for, like, I don't know how I'm going to implement it. I'm undiagnosed ADD. I'm never going to get around to the implementation of this stuff. But I was hoping someone on the project is going to get around to implementing, finding things once you get that image, by RFID, QR code, pings, heartbeats, fingerprints, whatever you would want your robot to be able to go find in the world. But I think back at the time, I didn't know to add the buzzwords of augmented reality or machine learning. If I just keep saying that, everyone will go like, oh my gosh, here's the money, go do it. What was that? Blockchain. I'll come back to that. I got a blockchain joke, and I'm tempted to ruin it. But anyway, so now if you want to be like totally walking out of here with money bags, like in that whole Venn diagram of passionate about things, and you're good at it, and oh my gosh, there's a whole bucket of money in what we're doing here, just keep telling everybody back at work, like augmented reality is really the OpenCV library and the WebDriver library. You do all those things, but we have to rename it to Star Driver. And there you go. That's the magic that we can kind of literally, test cheeseburgers with robots, as we saw in the video yesterday. Anyway, so I got one more thing. As far as it's kind of my general commandment to most people when they give a presentation is to end it with a link to a GitHub repo. So there's a whole bunch of cool story bro aspect to this stuff. Like, okay, great, robots, yay! Like, how is this useful? Anyway. The original name for that programming language, like that augmented reality thing to find the cards, I was very unoriginally called it code cards. But once I kind of put that on text, I think I even called it in the code cards in the video, it reminded me of the other thing that I loved playing around with as a kid that really got me into programming, and it was a language called HyperCard. Right? Like, same metaphor, it was like this stack of cards. And this is like PowerPoint before PowerPoint existed. I don't know if there was actually an inspiration there, but I programmed in HyperTalk. That was the thing that you'd program in. Fun fact, the original name for HyperCard was supposed to be wildcard. And so if you look in the file format, it was actually WILD. Apple had like 4-digit or 4-letter code names for everything. So at the last second, it was called HyperCard, but it started out as wildcard, which of course is a wildcard is, as we know, like an asterisk, right? Well, this is where things get spooky, right? If you look up the ASCII character code for what an asterisk is, it's 42. And you can fact check me on this. If you open up a Python prompt, and I don't know why it's called ORD, but spooky, I live in Chicago, and the code for O'Hare Airport is ORD. But anyway, but if you look up whatever, the ordinal, I don't know, the ASCII code for an asterisk is 42. And if you Google the answer to the life, the universe, and everything, the answer is 42. March 2nd, 1976, I was born. 2018, 1976 equals 42. So I am literally standing here on my 42nd birthday, imploring you to implement this idea. I'm like that guy in Close Encounters of the Third Kind who made that mountain out of potatoes. This is my mountain of potatoes. So with that note, I have implemented the code. One of the things I realized is that I've got an AR component to it, but if I'm actually specifically implementing a language, there's a whole other aspect to it of like the grammatical structure to be able to find these things and know a program needs to assume a beginning and an end and what's in the middle, and commands come first and then the other one. The thing I actually discovered is that I'm re-implementing the logo language, which, yes, for the 3 people. But the other weird thing is that that was created by Seymour Papert, and his famous thing where he talked about this was a thing called Mindstorms, and Lego named their robotics kit, it's called Mindstorms, which was named after that. So everything that you do to do Lego robots is, it's all this architectural, or sorry, anthropological history, whatever, of the logo language that I'm kind of rediscovering. So if you kind of can zoom in there, but hello world, I'm really making logo, but an emoji, trying to be as annoying as possible here. So hello world is a waving a hand and the picture of the globe. That's my hello world for my language. I have to get it up on the hello world sites of the world, right? But there is code, at least for the implementation of the language, and it's all up there, and the tests are quite extensive. And again, that second from the bottom, that would be, I was playing around again with the implementation for that program. And the tests run fast. There's really nothing else there, but hey, I've got tests. It can parse the programs, and it's super fast. And this is just new in the world, in the wild this week. So wildcard.org, and the code is up on GitHub. And you can start playing around with it. And granted, this is a kind of, again, my hack to the project. There was a really annoying thing at the very beginning of the project where it was HTML tables, and you had a program in this thing that no one programs in. So the way to get augmented reality is that you need to code an emoji. And I'm doing that to you. Someone else will come up and rip out the emoji and put in the Java bindings. And my secret to this is that this is the parable of the stone soup. You bring this like half-finished idea, and you piss off a whole bunch of people who obviously see what parts need to get ripped out, replaced with the better parts. And so by making an emoji-based programming language that can do augmented reality, that potentially can enable all of the testing of all the things, you can kind of go play around with that. Get annoyed with something, give me a pull request, and then welcome to the project. So that's it. Thank you. Would you like to see the big track go?
Yes.
You know, the other weird thing, total like, you know, spooky subliminal messaging here. There's not that many buttons on here, but there's a test button. Interesting. There's 2 modes, carpet mode and like hard floor modes. I think that's carpet mode. So I'm going to press the test button. Let's see what happens. There's an awkward pause, and it's going to be 3 seconds longer than you would think an awkward pause would be. It's still going to be awkward. It goes forward, fires the torpedo cannons, and then at this point you think it's broken, and then you start walking, and that's it. And if you want it to be a little 4-year-old playing with stuff, go forward 3, turn right. I think this is like clock stuff. So 30 would be like 6 o'clock, and then go forward 3 again. I hope I programmed that right this time. So this is how I test the stuff I'm working on these days. All right, that's it. Thank you.